definition of functions, limits of the functions. Now we're going to be looking at examples on how to find the limit of a function. We have different methods of finding limits of a function. Methods. Method of finding limits of a function. The number one method I'm going to be talking about is the substitution method. Substitution method. We also have the factorization method. And lastly, we have the L'Hopital rule method. So these are the three methods we can use to find the limit of a function. To begin with, I'll start with substitution method. Let's do one or two examples or as much examples as we can using the substitution method to get the limit of a function. Let's say you are given a question like this: limit as x tends to 0 of 2x over 1 plus x. Just as the name implies substitution, when you are given the value of x, what you just do, anywhere you see x, you input the value. What do I mean? Here we already told that x tends to 0. It means x is approaching 0. That means anywhere we see x in given limit, we substitute the value of x given to us. So we have this, we have it to be 2 into 0 over 1 plus 0. And this is also equal to 0 over 1, which is equal to 0. See how simple it is. Now let's look at another example on this. We have, let's say we are giving limits as x tends to 2 of 3x plus 5 all over 2 plus 1x, or let's just say x. Just the way we did the number one. The only difference here is the limit that we're giving. Here we're giving that x tends to 0. Here we're giving that x tends to 2. And the function is changed. So wheresoever we see x, we are going to substitute the value, which is what? 2. So we have it to be 3, 2 plus 5 over 2 plus 2. We have it to be 3 times 2, which is 6, plus 5 over 2 plus 2, which is equal to 6 plus 5 is 11, and our 2 plus 2 is 4. And when we change it to mixed number to give us, what do we have? 2 whole number, because 2 times 4 is 8, 3 over 4. So this is our answer. So you see that the substitution method of finding limits of a function is so simple and easy. Just substitute the value given to you to the given function. Now we'll be moving to the second method, which is the factorization method. Factorization method. So we'll be solving some examples using the factorization method. Let's say we are given a question like this. Evaluate limits of t squared plus t over t squared minus t as t tends to 0. Now please take note of what I'm about to say. Before you use the factorization method or any other method, first check the substitution method and see if it is applicable to the function. Now let's look at this using the substitution method first. By the time we substitute our value of 0 in each of these terms, we have it to be 0 squared plus 0 over 0 squared minus 0. And in all, we have 0 over 0. And 0 over 0 is undefined, or should I say cannot be solved, cannot give you a specific value. So it's not specific. The answer we won't get this. If you punch it in some calculators will say math error, some calculators will say undefined, while some will tell you infinity and the rest. So just know that substitution method cannot work here. So we try using the factorization method. From here, we have t squared and we have t. Here we have t squared and we also have t. It's very obvious that t is common in each of them. So you factorize by bringing out t. And when you bring out t, we have t plus 1 over, also bring out the t here, we have t minus 1. So from here, we have our limit as t tends to 0 of this t will cancel this t and we'll be left with t plus 1 over t minus 1. So we can now substitute our value of t, which is 0. When we do that, we have 0 plus 1 over 0 minus 1, which is equal to 1 over 1, which is equal to 1. Alright, so let's look at another example. Let's say we are also giving evaluate the limits of 2x squared minus x minus 21 all over x plus 3 as limits of x tends to minus 3. Now, just like I said earlier, you substitute using the substitution method to check, most especially the denominator. If we substitute our minus 3 with the denominator here, you find out that everything here will become what? 0, which will make our answer undefined. So that simply means substitution method won't be applicable. We now use our factorization method, especially when you know that the given function or one of the given function is factorizable. That means you can be able to factorize it. Like this one we have here, the numerator we have here, we can factorize it. So let's factorize it and see what it will give us. So we have limits as x tends to minus 2 of, just like the way we do our normal factorization, we multiply the coefficient of x with our constants. 2 times minus 21 to give us minus 42, and then we look for the factors that will give us minus x. So I know No, 2 is also a factor. Then 3 is also a factor. We'll get 42. 3 is also a factor. But the factor that is applicable here is 6. Remember when we multiply 2 times minus 21, we got minus 42. So 2, the factors, 2 times minus 21 is a factor. Let's look at 3. 3 times minus 14 is also minus 42. Then 4 is not a factor. 5 is not a factor. Also have 6 times minus 7 will give us minus 42. Then even 1, yes, 1 times minus 42 itself is also a factor. Now, all these two, we can also do it the other way. What do I mean by the other way? You can say 42 times minus 1 give you minus 42. Just this first one, you negate them, while this one, you make it positive. That is, we have here minus 2 times 21 minus 42. Also have minus 3 times 14 give you minus 42. Then 6 minus 6 times 7 give you minus 42. So all these are the factors of minus 42. Now from these factors, we have to look for the one factor or the two factors that when you simplify them together will give us a negative x. When you do 42 minus 1, it will give us 41. Obviously, it's not giving us minus 1x. So, it's not it. Same here too. 1 minus 42 will give us a negative 41. 2 minus 21 gives a negative 19. 3 minus 14 will give us a negative, is it 9? No. 11. A negative 11. 6 minus 7 will give us a negative 1. So I think these two are the factors, because 6 minus 7 is negative 1. Why minus 2 plus? Since there is no negative here, there is an invisible plus, which can only be seen by those with mathematical eyes. So we have negative 2 plus 21 is going to give us a positive 19. Negative 3 plus 14 will give us a positive 11. And negative 6 plus 7 will give us a positive 1. So our factor here, our factors are this. So we start solving. We have 2x squared. Now, there is no negative here, so that's plus 6x minus 7x. These two things are representing this. Then you have your minus 21 all over x plus 3. Okay, so we have limits as x tends to minus 3. Yeah, you group them now. Let me use the solar brackets. Don't mind my brackets. So we group them together. And because I want to group them, enclose them in brackets. That means we have 2x squared plus 6x. We have our minus here. Then you have 7x plus 21. Now, take note of this. Here, we are having minus here. I changed it to plus. That's the rule. The sign here must be the same as the sign here. Why? Because actually open this bracket with this minus, we eventually get this back. Minus times 7x will give you minus 7x. Minus times plus gives minus, and you have your 21. So we have x plus 3. Then you close the bracket. Now also, let's continue. what are the common things here? 2 and x. So 2x is common. We bring it out and we have x plus 3 minus 7 is common. We have 7 of x plus 3 all over x plus 3. So let's enclose this in the bracket just to make it more fine. So when we simplify this further, these two are common. We have it to be x plus 3 into 2x minus 7. This 2x then minus 7 is it over x plus 3. And this will finally give us limits as s tends to minus 3. Now these two can cancel, they are exactly the same, and we'll be left with 2x minus 7. We can now substitute our value of x. So this will give us 2 into minus 3 minus 7, which is minus 6